Just a little bit of background. Nick Foran Fire Response. We're based out of Newcastle. I guess what we're presenting today is like about 18 months worth of in-field research that we've been doing on cannons and water carts and foam. I guess the first question I've got, just to get a show of who's in the room, how many people are in the underground? Here, yep. Open pit? Right. Even though I'm going to say picking on water cannons today, what we're saying is relevant to all foam proportioning equipment. Right, so just think about how it can be relevant to your operations. I guess part of the reason we started doing this, we represent an American brand of cannons by one of the world's largest manufacturers. We also import high-performance firefighting foam out of Spain. So in part of our due diligence was actually start testing our systems for compliance. We started testing our foam for compliance. And because our systems were used with other systems and foam, we started testing those as well. So at the end of the day, we've actually tested a fair bit of equipment out there, and some of the results are quite interesting. Do I just click on these? Just on my name?
Yep.
Okay. There we go. At the end of the day, what we're trying to achieve through this testing is improved standards around water carts. At the end of the day, a lot of the mines and a lot of the OEMs are just putting cannons in there for compliance without actually speccing this up properly. And through our testing, we're actually working out what actually works and what doesn't. So the idea here is, through innovation, is to limit risk, learn from other people's mistakes, with the view of actually improving specifications around cannons. The cannons on the water carts, whether we like it or not, they're either a primary firefighting device or a secondary firefighting device, which puts you in the realms of where a fire truck is. So what we're trying to do with some of this testing is actually bring in some fire truck standards and foam standards and testing with the view of making a better system with the water carts. Some examples of where, I guess, water carts are required. If you look at number one there, that was a large fire. I'm not going to name names of businesses, but it was actually a 773 service truck in a shed, lancing a pin out. It took 14 hours to put this fire out. Foam ran out in about 15 to 20 minutes, and the water carts went into structural firefighting mode, so they were actually cooling everything else. The only thing they lost here was the shed, but they pulled out a tow haul, crest hauler, and there was oxyacetylene tanks within 10 metres of this fire. The EX5500 into number two, a two-week-old machine burnt down. The water carts at that site didn't have their cannons operating effectively. Number three there, a 773 service truck, full of fuel was leaking, started the fire, and the only thing the site could do there is actually just let it burn. And number four, everyone's probably aware, there was a big coal mine fire in Victoria a number of years ago. It was a state emergency at that point. The power station was shut down, there was issues with power supply for the state, and the mine threw everything at it. Every fire truck they can get, every water cart they can get, they test every single foam on the market on all types of foams. So whether we like it or not, the water cart's pretty critical. And if you are carrying, I guess, the cannons on there for compliance with foam, you at least want to make sure they're going to work. So the bad news is, out of the 31 water carts we've tested in the last 18 months, 30 have failed in terms of flow rate and line pressure testing when we're benchmarking to like a big water cannon or a fire monitor on a fire truck. And of those 31 water carts, the foam proportioning test, only 2 passed. Pretty scary when you've got operators going out there to fight these fires and they think they're actually going to work. So I guess how we've gone about doing this, we're actually looking at a number of elements on the water cart. So we're looking at the foam line plumbing to make sure the foam tank to the foam proportioner or the cannon is actually as per what the manufacturer says, and if it's not, highlight the issue and get it fixed. Where we're saying plumbing to the cannon, that's the whole water delivery system. We're making sure the water delivery system's meeting the requirements of the foam proportioner, but also the actual cannon itself. Foam capacity is important. You want to make sure you're actually carrying sufficient foam as per standards to meet the largest fire risk on site. Lots of mines don't do it. How we're doing is actually through flow rate, line pressure testing and looking at friction loss to the cannons and whatever. An interesting component of it is at point 5, operator training, where we're actually capturing foam and water samples out in the pit under live fire conditions. All operators, in my view, weren't competent. They didn't know how to actually attack a large B-class fire. Point 6, we're actually looking at cannon configuration to make sure it's all set up, it's ready to go, fault-free, before we actually start doing the testing. And the last point, point 6, is the type of foams. The types of foams which are out there, for no one's fault, are actually really problematic. So getting back to the cannons, either electric, hydraulic or manual, that's what we're seeing. We're making sure the cannons are set up consistently, or looking for that, because from an operator's perspective, they get quite frustrated when the cannons aren't working and all the configurations are different on the truck. There becomes a perception that there's cannon issues, but actually it's falling back to maintenance and how they're actually configured. This particular system we're showing you there is just showing you how we do it. A fairly expensive inline flow and pressure meter, which is used by FPA for testing hydrants. How we're using it is slightly different. We're actually measuring the flow and pressure at inlet to the foam proportioning system. And this particular system was the only one that's actually passed. Look, it's one of our systems, but it's not the point. It just proves if you're actually using equipment that's made to standards, recognised standards, and you give the system exactly what it wants, you're actually in a good place of systems actually working. This is the boring bit, just bear with me. Some of the standards we're actually referring to, these are critical, and it would be really good if the mining businesses would actually have a look at these and consider these, not just in your normal foam proportioning devices, but your water carts. NFPA 11 is used by fire engineers around the world. You're actually doing foam proportioning tests to this standard, and there's actually mathematics around how much foam and water you need to put out a large B-class fire under this standard. NFPA 1964 is another one for the nozzle on the end of the cannon. If your water delivery system's supplying the actual nozzle itself the right flow and pressure, it'll actually aspirate the foam, or agitate it as we say, and create enough sufficient bubbles to actually help suppress that fire. Then we're actually looking at the actual cannon itself, like is it made by a recognised manufacturer? Are they used offshore? Are they used in other industries? And a big one on the foam is EN 1568. It's a European standard for foam, and it's recognised under that standard for its capability around big B-class fires. If you want to know more about the standards, you can talk to me offline, because I can go a fair while on that one. Look, the typical systems that we've seen out there, there's only been one system in the marketplace that we haven't tested, but points 1 and 2 is a fairly common system that we see. That particular system's not used by any fire brigade in the world, but it's common in the marketplace here. The testing that we've done and had it validated externally from us is we haven't been able to get that system to proportion accurately. Point 3, that's the system we have that has passed the relevant standards. Point 4 is another type of foam proportioning device, fairly common foam injection system. That system's not used by any fire brigade or large industrial facility around the world, but it's quite common in the mining industry. And again, we haven't been able to get that system to proportion accurately. Point 5 is just an example of a manual cannon. A few sites actually still use those with foam proportioning. And if you look at point 6 and point 3, point 6, even though we've proven that system works, you'll actually see that foam line's actually rather small. So that creates an issue with your foam proportioning. So depending on what foam you're going to run, it hasn't got a chance in hell of working. So what are we looking for? We're looking at visual testing or visual setup of the systems. The first point we're actually looking at is the flow and line pressure to the actual, either to the foam proportioner or the nozzle. If that doesn't actually, if it's not set up properly, it's no point going to the last point of doing a foam proportion test because you're actually just going to waste your money. So if you look at graph 1, what we're trying to show you here is the red point is the BTU of the fire, so the energy of the fire. So as the fire gets angry, the best way to describe it is a graph. It's going to go up like that. So if everything in the water delivery system, your foam's set up, it's proportioning accurately, the whole lot. The idea of the foam and water is to get on top of that fire and actually suppress it. If you go to point 2, under the same conditions, but there's some of the variables are not set up right on the truck, the energy of the fire is still going up, but the foam's plateauing. So you're not giving the foam and water solution the right capability to get on top of that fire. So from an operator's perspective, they're going out to a fire, the white fluffy stuff's coming out, there's a perception it's going to work, and they're wondering why nothing's working. So you don't know this until you actually start doing some testing on your foam proportioning systems, either 6 months, annually or whatever, to work out if it's going to work. Fire brigades do this. From what I'm seeing, the mining industry doesn't do it. So again, that's a good point to take home and maybe consider at your operations. So this is how we do it. We use the cannons in angry mode, as I say. So we're capturing a foam and water sample. A lot of the time we're actually doing this in, like say, a wash pad, so we're actually trying to capture the foam and water sample itself to contain where it's going on the ground. But once we get that, then we're actually sending it off for analysis, and it's actually getting done via NFPA 11, which will basically say if the percentage on your foam container is 3 or whatever, and you're like 2.99 below that, that's a fail. And depending on the type of foam you're running, it probably won't work. So it's really important that you consider this. This is a Generation 2 Caterpillar water truck that happens to be running one of the systems we were talking about earlier. Compliant to NFPA standards. The water delivery system set up perfectly. The foam they're running, they've actually got a good supply of foam there to meet NFPA 11. The foam blanket is a pretty good foam blanket. So this one here is actually in a really good spot to go out and actually fight a large B-class fire. So one of 2 out of 31 trucks. So I guess the main issues we're actually looking for is it, through the configuration, is it under proportioning, which means you're not getting enough foam into your circuit? Is it over proportioning, too much foam going in and the foam doesn't have the capability to work with too much going in? Incorrect mixtures. And then we're actually looking at the certification on the foam to make sure, as you'd appreciate, mines quality water is not potable water, it's not drinkable water. And in real life situations, you actually want the highest possible certification on your foam, because once you start putting recycled water, raw water on, your certifications come down, and it can get to a point where if you're on a marginal certification, it's just never going to work, even if it's set up. This one here is just showing you a couple of different types of foams. And I'm not going to bore you with this because talk about this one for ages. But Newtonium, non-Newtonium foam. Okay, the one on the left is the Newtonium foam. I don't know if I turn that. Newtonium foam is designed for diesel and oil. It's fairly common in vehicle suppression systems. The one on the right it's a multi-class foam, so this is what the fire brigades will use. Yeah, just Spanish people in the background. The fire brigades foams are quite problematic. Queensland Fire Service was the first one to transition over 10 years ago. Fire Rescue New South Wales is second, and everyone's having issues with this foam. If you're running these thicker type foams, they've got some characteristics which are problematic. So you can see there, it's like putting molasses into water. The only way you get that working is actually preheat your foam and water to get it to go in there. Other than that, over time it's going to separate. Or if you actually put it into a fire truck, and I've seen this firsthand, where you actually pre-charge a foam line and you try to use your fire truck and it doesn't work. And this one here is another example of the pseudo-plastic or fire brigade foams. These ones here, all we've done was pop the lid on various foams and we've just sat them in the warehouse. So picture them on a water truck where they're actually, you've got free to air in your tanks, and this is what's going to happen to your foam. You don't know this is going to happen until you actually test it, or you go out there to try and use the system in anger on a truck and all you've got is water coming out or nothing's working. So again, it's really important to go back and test, do some type of maintenance and look at your systems to make sure you've actually got the right foam for the application. There are certain applications where you have to use this foam, but in most applications you can use the Newtonium foam, which you don't have these viscosity issues. So that's the end of it. I can go on a lot further with that, but I'll try to keep it short and sweet, so at least there's some good take-home points. I suppose if there's any questions.
Yeah, if we do have any questions, can we use the microphone, please?
Questions, folks?
Thank you. Yeah, I guess maybe an obvious question, but PFAS has been a pretty big topic. So all these new foams wouldn't have PFAS in them, I'm assuming.
100%.
Yeah.
In Queensland, to have any type of firefighting foam in Queensland EPA has actually led the national market. So everyone's benchmarking off that, which is basically saying the foams have to biodegrade to at least 80% within 28 days. Like I know the particular foams we have, they're actually biodegrading to 90% within 7 days. But most of the competitors are well beyond that benchmark.
Well, it's a bit different to PFAS, isn't it?
Look, you've got to understand,
Sounds good.
with these fluorine-free foams, they're actually substituting different chemicals to get the performance of fluorine. Okay, fluorine in foam is actually really good. It's just not good. It's just hard to manage once it's on the ground.